Welcome. For 50 years, people have tried to turn software from craft into industry. Today, let's discuss how the software factory had developed today's AI agents and beyond. In the late 1960s, software was still a craft. Programmers worked alone or in small teams, writing unique code for every project. Productivity varied wildly. Robert Bemer, a computer pioneer, saw the problem clearly. In 1968, he proposed a software factory to standardize tools and share databases to reduce variation. That same year, at a software engineering conference, McIlroy argued for mass-produced software components. Modular reuse could turn programming into something closer to manufacturing. Hitachi moved first. In 1969, at Hitachi Software Works, the world's first software factory. The goal was higher productivity and reliability through standardization. Japanese companies treated software the way they treated hardware. Hitachi and Fujitsu each built large, centralized facilities with strict processes, training, and quality controls. In the United States, System Development Corporation, its software factory in 1975. It standardized procedures and tools that acted like an assembly line. SDC's experiment influenced Japanese managers. The Japanese factories emphasized process discipline, measurement, and systematic reuse of code modules. Michael Cusimano later documented these efforts. Japanese software factories achieved higher productivity and quality than many American craft-style shops of the same era. The factory model rested on three ideas: standardized methods, 2, reusable components, and 3, management systems that made results more predictable across projects. Yet software resisted pure mass production. Requirements changed, creativity still mattered, and perfect reuse proved harder than expected. Many early factory efforts faded or evolved. In the 1980s and 1990s, the idea lived on under different names: software product lines, process improvement, and later DevOps. But the core desire remained to make software delivery more industrial. Microsoft revived the term software factories in the mid-2000s, focusing on domain-specific languages and product line engineering inside Visual Studio. Defense organizations kept the language alive. Software factories became collections of people, tools, and processes that continuously delivered software. By the 2010s, the bottleneck was still human coding, and delivery helped. Continuous integration maintaining large systems still scaled mainly with headcount. Then foundation models arrived in 2022. Large language models could generate, explain, and refactor code at speed no individual programmer could match. Agentic software emerged in 2025. An agent does not only answer questions. It plans, uses tools, maintains context, and takes multi-step actions toward a goal. Today's software factories are being rebuilt around agents. The assembly line is no longer only human teams following procedures. Agents now occupy many of the stations. Coding agents write functions, tests, and documentation. Review agents examine pull requests. Testing agents explore edge cases. Companies such as Anthropic and OpenAI have demonstrated long-running agents that can operate for hours or days on complex engineering tasks. And enterprise adoption is accelerating. Organizations report rising numbers of agents in production, especially for customer service, IT, and software engineering workflows. Yet most companies remain in the early stages. Many run single agents or simple chains, fully orchestrated multi-agent systems that coordinate across common. The new factory requires more than models. It needs identity, memory, and tool access. We also need guardrails and audit trails between agents and humans. Process readiness lags capability. Most business processes were designed for people. Redesigning them so agents can own end-to-end workflows is hard work. In the agentic factory, humans shift roles. Humans set goals, define constraints, and review critical decisions, then improve the system of agents rather than writing every line of code. Quality becomes a property itself. It involves continuous evaluation, automated testing of agents, and feedback loops that refine both models and processes. The current state is transitional. Agents handle increasing shares of routine work, while humans still own architecture, novel design, and high-stakes judgment. Looking ahead, the software factory of the future will treat agents as first-class workers. Teams of specialized agents will collaborate the way human teams once did. Management agents will interview stakeholders and generate specifications. Design agents will propose architectures. Implementation agents will build and integrate. Verification agents will continuously test. Security agents will scan for vulnerabilities. Operations agents will observe production and propose fixes. Human oversight will move higher. People will approve goals, set policy, and intervene at decision points that carry legal, ethical, or strategic weight. Software itself may become more fluid. Systems will be generated, adapted, and retired by agents in response to changing needs, rather than remaining static artifacts. The boundary between building software and running the business will blur. Agents that understand both code and operations will optimize processes end to end. Productivity gains could be large. Organizations that successfully industrialize agentic development at speeds previously thought unimaginable. Risks remain. Agents can amplify errors, create opaque decision trails, and introduce new failure modes. Governance and accountability become essential factory infrastructure. The future of AI in this domain is not simply faster coding. It is the transformation of software production into a continuous, largely autonomous industrial process. Just as the original software factories sought to replace pure craft with engineering discipline, agentic factories will replace manual labor with coordinated machine intelligence. Success will depend less on any single model and more on the quality of the factory, the orchestration, the data, the feedback, and the human judgment layered on top. In time, the most advanced organizations may treat software the way modern manufacturers treat physical goods, designed once at a high level, then produced at scale. The history of the software factory began with a simple insight. Programming should not remain a purely individual craft. That insight is now being realized at machine scale. From Bemer's proposal and Hitachi's first factory to today's agent-driven pipes, the trajectory is clear. Software is becoming something we manufacture, at scale with intelligence.